Hello, YouTube. Hello. Okay, no one's there. Yeah, what do we do? Okay. All right. What is up? What is up? What is up? All right, I guess we can start. Okay, we shall start. Is it because of Ramzan that everyone just sleeps and at 4 in the morning they get up and they're studying? Is that how it is? Mesam, how come you're on YouTube? Why no Zoom? But okay, fine. If you want to be on YouTube, how are you? Okay, let's start with this question, but Miral can't see my screen right now because I haven't enabled it. Let's start with this. We're doing paper 4-1 November 2019. Paper 4-1 November 2019. We're looking at a question in where electrolysis is taking place. The student electrolyzes 3 different solutions. I have the wrong pencil selected. 3 solutions using the apparatus shown. So it's a basic electrolysis setup. Complete the table. So these are the 3 solutions: aqueous copper sulfate, potassium iodide, dilute sulfuric acid. Okay, so they've done most of the first one for us. Okay, so oxygen is produced, bubbles of a colorless gas at the anode. That makes sense to me. And over here, the compound being formed is copper. What observation will we make? What observation? What color is copper? So it's going to be a pink solid formed at the or on the cathode. Okay. Aqueous potassium iodide. Aqueous potassium iodide. Now I don't need to worry about it too much. I know brown liquid is going to be what? I know iodine is produced. Now what do I write? Do I write I minus? What do I write? It says oxygen in the first one, so I'll just write down iodine. Right? I want to change my color. Okay, brown liquid, and name of the product. So what's going to happen at the product? We have what positive ions present here in the solution. So the positive ions for aqueous potassium iodide will be, where can I write this? Let's write it here. H plus ions and potassium ions. Which of the two will discharge? Now potassium is at the top of the reactivity series and hydrogen is close to the bottom, and hydrogen will discharge because ease of discharge increases as you go down the reactivity series. So hydrogen will discharge. Name of the product will be hydrogen. And how will you see hydrogen? It'll be bubbles of a, I don't have enough room to write. Bubbles of a colorless gas. Unfair that they didn't give us enough room. Okay. We're left with dilute sulfuric acid. What's going to happen? Bubbles of a colorless gas. Now at the positive ion, you have the sulfate ion showing up, and you have OH minus ions, right? Which of the two will discharge? Well, it's always water, isn't it? This will discharge. And OH ions, sorry, I said water, I meant OH ions. And when OH ions, when they discharge, what happens? What do you see? It forms water and oxygen. But water, you won't see that formed, you'll only see the gas formed, which is oxygen. So oxygen is formed. And what about the other side? Dilute sulfuric acid. You only have hydrogen for as the positive ion over here. Only hydrogen. So I guess hydrogen will be formed. There's no other positive ion present. Hello Junaid, what's up with you? Rouge does an elbow cough. What's up? Give a test and observation to identify oxygen gas. What is the test? Bring a, you can just say glowing splint. Bring a glowing splint. Do you guys know what a splint is? Relights a glowing splint. Yep. Miral says, yep. So far, they will be conducted in Pakistan. And Junaid, I like your J. Very googly. Or should I say jugly? That doesn't make sense. Okay. Calcium carbonate, a rate question, I believe. I think. Calcium carbonate reacts with dilute hydrochloric acid. And we've seen this equation a lot. Student investigates the rate of this reaction at 3 different temperatures using the apparatus. It's a rate question. In the experiment, the student adds dilute hydrochloric acid to an excess of calcium carbonate. The volume of carbon dioxide in B is recorded every 30 seconds. What is meant by excess of calcium carbonate? What is meant by excess? It is the amount that's like the amount is more than that's needed, right? So let's try writing that, phrasing that in nice little English. I'm going to use a different color. More than the needed amount. Needed amount to complete our reaction. And how would you guys have answered this if they asked, hey, excess? Well, yeah, okay, H ions, sure, ठीक है. But they're talking about why calcium carbonate is the excess one. So if you say H plus, you'll be incorrect. Isn't that right, Abdullah? But I think you only misread the question rather than anything else. Name the 2 pieces, A and B. What is A? This question just shows up every time. What is A? It is a conical flask. What is B? I'll just go up. If you guys want to, take a second to say it out loud before I write it. It's a what do you call it? A gas syringe, right? Or yeah, gas syringe. Gas syringe. Some people like to call it a graduated gas syringe. That's fine as well. Graduated just means it has markings on it. Greater than the required amount is more than enough for me, Malik. ठीक है. Student does experiment 1 at 20 degrees, exactly at 20 degrees. Name a piece of apparatus that can be used to keep the temperature constant. What do you guys think? I'll just take a good 15 seconds to answer this. What do you guys think? How do you keep the... Numan, I don't think they'll be cancelled. At this point, I think there's no point cancelling them because all the effort is done. Might as well just go and take the exam. Unless, it's not, then you always have the option to take it in November, which, is not going to be an issue, I feel. Okay, how do we keep it constant? No one has answering it. I'll answer because we can take. Javeria answered. Awesome. You use a water bath. If someone wants me to explain this, what are you talking about? Water bath, what? Someone let me know. Electric heater. Yeah, I think water bath is more consistent. It's very interesting why water bath works. Student does 2 more experiments. Experiment 2 at 40 degrees, experiment 3 at 60 degrees. I forgot what this experiment was at. (20 degrees). The first experiment was 20 degrees. Let me just write that here. Experiment 1 was at 20 degrees. So this is going to be the fastest, second fastest, slowest. So just 2 variables that the student keeps constant so that the temperature is the only variable that affects the rate of reaction. What are the factors affecting a rate of reaction? Electric heater, I think you can say it, but I think the water bath is the way to go because that's common practice. You'll get a similar result like, yeah. What do we keep constant? Of course, concentration of the acid used. What's next? Concentration of the acid, and this is the 3rd time I'm doing this question. What's the other thing? The size of the particles for calcium carbonate. Size of the particles for or marble chips calcium carbonate. Anything else you guys can think of? Room temperature, I mean, you have to actively try to change, right? Room temperature won't really change unless... Oh, I paused my recording on Zoom. Oh well. Pressure won't really change. How, like you have to actively try changing pressure, Miral, right? Like how would pressure change? When you're cooking something, unless you use a pressure cooker, is your pressure ever changing? No. You don't have to worry about the pressure changing. So you don't have to control it. It's already controlled, right? So what else is there if not pressure? Volume of what, Javaria? Volume of moles of calcium carbonate? Yeah, actually. But what was... let me go back here. Excess of calcium carbonate. So I think what Javaria was saying, I think she said volume of hydrochloric acid would be a better answer, the amount of acid used, moles of acid. Actually, the volume, the moles of acid could also be higher. That would just produce a steeper graph. Not steeper, I mean, like it would end at a different point. The volume of carbon dioxide produced will be different. But as long as the concentration is the same, the volume will be the same. Okay, Javaria, did you follow what I'm saying? So if you're using more acid, and if you're making sure you're, if you're making sure your volume is fine. Sorry, what was I saying? I'll wait for Javaria if she gets it. If she gets it, I'll move on. Actually, I'll move on. I won't go back to it. Okay, student plots the graph of the results. Experiment 1 to 3. Describe the graphs used to decide which experiment is the fastest rate. The one with the steepest gradient. How do you spell steepest? Steepest, I don't know if that's the word called. Steepest gradient will be the 1. Write a number in each box for the identity experiments 1 to 3. experiments 1, 2, 3. So the fastest one is going to be at the highest temperature, and we already marked this, we already did this. It's going to be 3, 2, and 1, right? If I'm not too wrong. That makes sense to me. It's experiment 3, 2, 1. ठीक है. I don't know if... Nawal, we won't say moles of calcium carbonate. They're already in excess. They won't change the rate of reaction. But you got to make sure they're in excess, I guess, but probably not the best point to highlight. Write a number in each box on the graph to identify experiments 1, 2, 3. We did that. State how the graph shows the reaction has stopped. The graph has become horizontal. Becomes flat or horizontal. Why does the reaction stop? Now you can't say calcium carbonate was finished, right? Because the calcium carbonate, remember, it's in excess. That's what the question is saying. We ran out of acid. Or I should say, all the acid reacted. Constant gradient, no. Constant gradient is not the right answer, Malik. Constant gradient technically could imply that the line is a, constant gradient just means line is a straight line. This line is a constant gradient. You can say the gradient is 0. That's a 0 gradient. Horizontal lines have a 0 gradient. But you cannot say constant gradient. That's incorrect. ठीक है. Moving on. Shall I spend some time here? Any questions? Miral, I think you're solid. I call Miral to class, but she doesn't need classes. Isn't that right, Miral? Maybe. Should we have an iftar party? Okay, this was a interesting question. Gradient becomes 0? Gradient, yes, Iman. Volume of carbon dioxide produced becomes constant? Abdul Rahim, again, that's incorrect. Volume of carbon dioxide, you could say no more carbon dioxide is produced. That will still be a better answer, but it's still not the right answer because state how the graph shows. How is the graph telling you the reaction is stopped? What are you looking for in the graph when it becomes horizontal? Reaction 1 stopped somewhere here. Reaction 2 stopped here. Reaction 3 stopped here. You're not checking volume of carbon dioxide kitna hai. You're checking for when the line becomes horizontal. And that's what they're asking. Okay, I hope everyone gets this. Okay. Carbon and copper oxide are both black solids. Copper oxide reacts with dilute sulfuric acid to form an aqueous solution. Essentially what's happening is there's copper oxide, which is a black powder, and there's carbon powder, which is a black powder. They're mixed together, and you want to separate it, and you want to figure out a way how to separate it. Mixture and they're telling you, they're giving you this big hint, hey, copper oxide will dissolve in sulfuric acid to form copper sulfate, and what else? I think copper sulfate, and something else, I guess, but copper sulfate primarily. Mixture contains carbon and copper oxide only. Plan an experiment to produce the ठीक है. You may use dilute sulfuric acid, distilled water, and any apparatus usually found in a lab. What do you do? What do you guys think? So essentially, what I want to do is take a beaker. I'll just, I'll take a beaker with the mixture. The mixture again, copper oxide and carbon, right? I'll put, sorry. I'll just draw it because it's just difficult. I'll take the 2 black powders, I'll dump it here. I'll put sulfuric acid, I'll fill it up with sulfuric acid. Everyone knows sulfuric acid is blue? No, it's not, it's colorless. I'll fill it up with sulfuric acid. Now what's gonna happen is carbon does not react with sulfuric acid. And I'll make sure I'll stir it as well. I'll stir it, all of this would go away, and I'll only be left with a bit of carbon at the bottom once it settles down because it won't dissolve. And the solution will turn blue because copper sulfate is not formed, which is aqueous. How do I now separate a solid carbon from a solution of copper sulfate? I'll just filter it. So that's essentially my plan. Can we phrase that in words now? 5 marks. Let's try to score 5 marks. Okay, I want to start with a good color first. Start with green. Very festive. We'll take a beaker. Place the mixture of copper oxide and carbon and add, my punctuation game is wrong, incorrect, and add sulfuric acid. To stir the mixture generously, or just stir the mixture? I think that's fine. Okay. So now what's happened, we're at the stage where the solution has turned blue because it's copper sulfate, it's filled with copper sulfate, and there are black powder carbon solid in there, right? Can I explain it again? Pika, you don't even take O-levels. Do you take O-levels, Pika? If you tell me you take O-levels, I'll explain it again. But I don't think you take O-levels, do you? Can I explain it again? Okay, other people are asking as well. What part do you want me to explain? Just highlight while I start from the beginning. Essentially, I want to separate copper oxide, which is a black solid, black powder, and carbon, which is also a black powder. So essentially, they've mixed 2 black powders together. And one can react with sulfuric acid and technically dissolve, while the other cannot. So first what I'll do is I'll take the black powder and dump it in a beaker. Then I'll fill it with sulfuric acid. I'll pour sulfuric acid in it. Once this reaction has taken place, the carbon in this would have stayed carbon, but all the copper oxide, which is a solid, will react to form copper sulfate, which will be aqueous or soluble in the solution. So dissolve ho jayega. So essentially, you're doing the same experiment as sodium chloride and sand ka solution. When you add water to it, the sand doesn't dissolve, but the sodium chloride does, right? Namak, salt, it dissolves. So essentially the same experiment. So this will dissolve and you'll only have pieces like tiny powdered carbon left, and everything will just be a blue solution because all that copper oxide has dissolved. Just add it in excess because you don't know how much. Just add until, just add it, right? Like you just eyeball it. You don't have to highlight it because you don't know how much you're starting off with. If you say 50 centimeter cube of sulfuric acid, that's incomplete information because you want to also highlight the moles. Then you know the moles. But you don't know the moles of copper oxide in it, so just give them the instructions and they'll carry it out when they need to. But we don't know how much sulfuric acid to add because they haven't told us, or have they? I don't think they have. I don't see numbers at all in this question. Okay, I hope this makes sense. You can write sulfuric acid, add sulfuric acid until it's in excess. I think that's better. Stir the mixture. Okay, I'll continue with it. Pika does take O-levels? I'm shocked. Pika, say Pika, Pika. Okay, I'll continue. Stir the mixture. Then what do we have after this? Difference between reacted and dissolved. That's a great question. How do I explain this? Over here, the reaction takes place because copper oxide does not dissolve in water, but it reacts with sulfuric acid to form copper sulfate, which is aqueous, which is soluble in water. So that's essentially what's happening. So see it as a two-step process rather than one. So yeah, like, I hope that makes sense, Anas. How else do I explain it? Pika, all right. ठीक है, okay, moving on. ठीक है, okay, the last thing we did was stir the mixture. Now we have to filter it. Filter, the next step is filter. Filter the solution using a filter funnel and filter paper. I'm just writing it, filter paper. The blue solution, so each color is more or less a mark right now. The blue solution which is aqueous copper sulfate will pass through leaving behind the undissolved carbon as the residue. Now, it's sulfuric acid. You want to make sure it's all clean, all of it has gone through. So what you do is clean your residue with distilled water. And finally, I'm out of colors. Leave carbon to dry, or maybe you can heat it if you want, but if you leave it to dry, that's the approach. Why waste time and energy? Leave carbon to dry and you will have your... We don't have to crystallize it. Why would we crystallize it? We're not trying to collect the copper sulfate crystals. We're trying to collect the carbon from it, right? We're not trying to make an insoluble salt. We're trying to extract carbon from it. We will not crystallize the solution one more time. I hope that makes sense. Because if we wanted copper sulfate, then we would do it. But we just want the carbon. We can throw away the copper sulfate if we want to. Miral, what do you think? Is Messam still here? What do you think? I'll just give this a second. I think people are very confused. Easy? Miral thinks this is easy. Hanan, welcome. How are you? I did not see you. Okay, OA. Techno gets it. Do you guys think I'm a boomer if I answer my WhatsApp messages or Instagram messages as Lamau? Like if I add Lamau? Techno got it? Okay, let's move on. Student is provided with 3 solutions. Aqueous zinc sulfate, or the same thing. Copper sulfate, calcium nitrate. Student tests the 3 solutions by adding reagents. I get anxiety looking at these questions because they're so big. Record the observations in the table. Write no reaction where appropriate. Okay. Just by looking at this, I find it interesting. Aluminum and aqueous sodium hydroxide, blank, blank. Hey, name of gas, test for gas, result of gas. Does that mean you won't have any of these things here? being produced here? Yeah, I don't think anything's being produced there. Why? What is this a test for? Can we just write it down? What is this a test for strictly? Aluminum and aqueous sodium hydroxide. It's a test for the nitrate ion, isn't it? This is for a test for sulfate ion. And these are like, your variety of tests, these two, the first two. Okay, let's see. Okay, so I'm just gonna quickly say sulfates are present in these two. So what's a positive test for barium nitrate with dilute nitric acid? Normally we use barium chloride, don't we? I think you'll get a white precipitate, isn't that true? White precipitate. White precipitate, because both of them have TK. And the last one over here will not have a reaction. No reaction. Right? And because this only has sulfates and no nitrates, we will have no reaction over here for the nitrate test. And no reaction here for the nitrate test. Barium sulfate, yep. Okay. The nitrate releases a gas which you test, and the result is, what is the gas produced? Now make sure you write the name of the gas, because that's what they're asking for. The test is damp red litmus paper. Oh, why am I not zooming in? Take it. And what is the result? It turns blue. How many of you guys are eating right now? Look at that. My anxiety has already halved. Aqueous sodium hydroxide reacting with zinc will give me a white precipitate that will dissolve in excess. Copper. I love copper. Copper though, like the first time I heard it, you just never forget it, right? And copper, is it insoluble in excess? Copper sulfate, it'll make copper hydroxide. I think it's insoluble. Insoluble in excess. Insoluble in excess. Why am I doubting myself? Aqueous calcium nitrate. White precipitate, which is also insoluble in excess. Calcium one I hate. It's probably not hate, it's just not the worst too. Okay. Candy trace, we do take live classes almost daily, 4 days a week. It's insoluble, that's what I wrote, yes, thank you. Thank you. And it's soluble in NH, so yeah, I can get confused with that. It's a little too, like, ratta, why do they do this? I don't know. Broken page. There's a solution J, which is bleach. A student does an experiment to determine the concentration of sodium chlorate, NaClO. That's bleach, guys. The student transfers J to a conical flask using a pipette. Why does student use a pipette instead of a measuring cylinder to measure 25? Oh my god. Because a pipette is more accurate than a measuring cylinder. Which other piece of apparatus could have been used to measure 25 centimeter cube of J with high accuracy? If you couldn't find a pipette, because they're tiny, you could have used a burette. They're pretty accurate. I think I misspelled burette. It has one R, doesn't it? You guys hate me because I can't spell. Student adds an excess of sodium iodide and excess of hydrochloric acid to the conical flask. Reaction occurs to form iodine solution. This solution is K. Okay. The amount of iodine produced can be determined by a titration with aqueous sodium thiosulfate. Okay, so first they react it with to produce iodine. They react it with sodium iodide and excess hydrochloric acid. Essentially, they force it to react with iodine, and then they titrate that solution. So it's a complicated procedure. And they're trying to figure out how much iodine, the amount of iodine produced can be determined by titration with aqueous sodium thiosulfate. Yeah, that's what they're doing. Solution L is the sodium thiosulfate. L is put in a burette and run in a conical flask until the end point is reached. Why is it wrong to wash the burette with water immediately before filling it with L? Because it'll dilute the solution L. If it has water droplets, it'll dilute it. Even 1 drop of water added to it will dilute it. What do you do? What do you do instead? That's horrible. How do you clean it then, if you have to clean it? You guys know? Dilutes the solution that needs to titer. What do you do? Do you guys know? Miral, what do you think? As water droplets will be added into the reading and it would be inaccurate. It'll dilute the solution. Exactly. No idea? What's interesting, what you do is you actually do clean it with water, but the last time, like you're rinsing it with distilled water, you do it once, thoda sa hilaya usse, then you throw it away. Then you add distilled water again, उसे हिलाते हैं अच्छी तरह, फिर फेंक देते हैं. Third time करते हैं, उसे हिलाते हैं अच्छी तरह, फेंक देते हैं. फिर 1-2 बार पता है क्या करते हैं? The solution that is supposed to go into the burette, you clean it with that. You add that solution, mix it, throw it. You add that solution, mix it, throw it. You add that mixture, clean it, throw it. And then it's clean. The only impurity in it is the solution that's already meant to go in there. So now it's clean. Isn't that the smartest thing you've heard, Miral? Give me an awesome emoji if you find that's like very impressive. Anan, what do you think? Is that impressive? Mesam is not here. I would have asked Mesam as well. Mesam, are you there? Using air something? Air could still have impurities. Wash it with an organic solvent, that would still be impure. But I understand what you're trying to say. It won't dissolve, but it could dissolve just a bit. But if it doesn't dissolve, it'll still be there. Yeah? You know, like organic solvent is what? Oil or ethanol? Or wait for it to evaporate? That's smart too. Yeah, but why wait when you can not wait? 9:39, I think we can finish this paper today. Okay. I'm gonna try my best to put values here. You guys help me. If I have something wrong, please let me know. Initial reading is 0. This is 24, 5, 6, 5, 6, 5, 6, 7, 8. 24.8. And this one is exactly 10, I think. 10.0. These values are on top. Final burette 23.4. The second one is 49.2. The third one is 33.6. And this is get some fancy colors out, man. 23.4. What's 49.2 minus 24.8? Someone tell me. Can we use a fractionating column for what? Dry water. Sir, can I dry the water? No. Because that's not good practice. If you wait for it to dry, you're adding impurities to it, right? Like dust can enter and it just makes, it's just a waste of time. Just clean it with the solution. Unless the solution's expensive, then you probably won't. Then you will probably wait for it. But the, but thank God you're not carrying it out. Is it 33.6? Why am I calculating it? 24.4, I think. What's 33.6? Oh, actually that one. 23.6. Two best values. What is the average? I would calculate it, but I already know this value because 23.4 and 23.6 average is 23.5 centimeter cube. Number of moles, calculate that. Let's get a good color now. Let's get this pink. It's been, I haven't used this all day, all class. Moles is equal to concentration times volume. Concentration is 0.05, volume is 23.5. Convert this to decimeter cube, where I divide this by 1,000, and this value comes out to be 0.00118. I think it's 1175, then you round it off, it's 118. Or should we go with 1175? 24.4? Why is everyone saying 24.4? Did I ask that value? Oh, I asked for it. Yeah, okay. It's looking for my calculator. ठीक है. It's not 1.175. Yeah, the lol has a value. Okay, everyone's going for 1.75. Let's go with that as well. Everyone's going for that value, the exact value. Use the equation to calculate the number of moles of iodine in the solution that essentially reacted. The ratio between these two is 2 to 1, and this is 0.001175. So this needs to be half of it. What's half of this value? Miral, do you think I'm very sonorous? I don't know what that means, but I'm assuming that means you're very good at, singing or humming. What's the word for it? Well-tuned? Sonorous just means soundy. Okay. What's the word for like someone who's gets the notes right? Well-tuned, but that's not the word for it. It's a phrase for it. Use the equation to calculate the number of moles of NaClO that produces the number of moles of iodine calculated in F. I'm completely lost. Use the equation to calculate the number of moles of NaClO that produces the number of moles of iodine. Huh? Oh, we have to figure this out. This was essentially the iodine in the second reaction, right? So they're saying, okay, how much NaClO ended up producing it? Essentially, this is what they did. This was in the original solution. They added these two into it to produce iodine, and then they titrated this with sodium thiosulfate, right, to figure the iodine out. So this is what they titrated it with. This is the experiment we did to figure this out. They figured this out because they reacted, our original thing, what we need to find out with these two things to produce the iodine which we found out. So if we know this, we'll also know this. I hope you guys figured it out. So this is what we knew. 1, to find out this. Step 2, we knew this because this was produced here. This is still step 2. But what produced this was this stuff, all of this stuff. And the goal was to find this out, which was, yeah. This happens very frequently in labs than you'd think. And it's not difficult, it's a lot of fun doing such experiments. Use the equation. Okay, so I know the iodine and what's the ratio? It's 1 to 1. So thank God for that. It's 0.0005875 moles. Answer would be the same. Techno already got it. Pika says, no, I don't think so. Mesam says, look at YouTube. Pitch perfect, perfect pitch. Pitch perfect. Yeah, that's what it means. Pika might have perfect pitch. Okay. The MR of NaClO, which is just 23 plus 35.5 plus 16. 23 plus 16 is 33, 39, 40, 50, 69, 70, 71, 72, 73, 74, 74.5. Am I right? Yeah, I think so. Use your answer to calculate the mass. The mass will be the moles times the MR, which are, the moles are 0.0005875 times 74.5. And if I put this in my calculator, 0.04376, I'll go with 438. 3 significant figures. Am I right? This is the amount in 25 centimeter cube. Calculate the concentration. Concentration is essentially something present in 1,000 centimeter cube or 1 decimeter cube. So if I have this much in 25 centimeter cube, can I figure out how much it is in 1,000 decimeter cube? This is going to be just be 0.438 divided by 25 times 1,000. And I think that's the same as multiplying the number by 40. I'll do that the long way. I don't want to make any mistakes. I'm getting 1.75 grams per centimeter cube. And I want to convert this into moles, so I'll just divide this directly by 74.5 and I'll get the right answer. I'm getting 0.0235 because I took 1.75, divided it by 74.5. Now you don't have equations for this. Let me know if you don't understand this. But I think it's a little straightforward. So I'm not explaining it. Techno, you want to be explained which part again? I, J, H. Anand, you're raising your hand. Are you trying to say hi or do you have a question? You're not raising your hand again, Anand? Anymore, Anand? All good? Oh, no problem. Techno, I wait for you. Part J, can I explain part J? The first one or the second one? So I can explain part J. So they're asking for calculate the concentration of NaClO. So you can use the formula, concentration is equal to moles per volume, right? So in 25 centimeter cube, this is the moles. You can just say, oh, 0.0438, divide that by 25, but this has to be in decimeter cube. So 25 needs to actually be 0.025, right? And if you look closely, that's essentially what I did. How so? Because I'm saying, in other words, I'm trying to take a different approach. Because I am a pioneer like this, I try to do it differently because I just like thinking about it differently. But if you find it confusing, I can do it the other way as well. What essentially I'm doing is, concentration is the amount of moles in 1,000 centimeter cube. That's what concentration is. Any amount of moles or grams in this terms, they're asking for grams per decimeter cube. So I want to figure out how much of NaClO are there in 1,000 centimeter cube of J or 1 decimeter cube of J. Bhai, agar 0.0438 are present in 25 centimeter cube, I'll just do ratios to figure out how much there are in 1,000 centimeter cube. 25 mein itne hain, so this divided by 25, multiply that by 1,000 will get me how much there are in 1,000. I hope that makes sense, and that's exactly what I did to get 1.75. But if that doesn't make sense, you can just use the equation. Concentration is, it says moles over volume, my bad, they're asking for grams. So it's going to be mass over volume. Because this equation is talking about concentration in terms of grams per decimeter cube. So you'd use the mass over the volume. But like, sir, we've never done this equation or anything like that, but if you look at this, it should make good sense to you what they're asking for. Because, like, we've been taught everything as a formula, and these things aren't really formulas. No one thinks about them as formulas. Especially you guys won't be thinking about them as formulas once you start doing A-levels or anything ever so slightly equation intensive. These are simple ratios. And it just makes so much, it's so clear to you once you start thinking like this, instead of, oh, the equation says this, so I'll do that. So if there's no equation about mass, I won't do any. You know what I mean, right? Don't be lakir ka fakir, I guess. I don't want to undermine anyone. If you do it, good. I used to do it, equations, but I'm just saying, if you want to, the best thing is do it with the equation, because that's the most accurate way, least clumsy way. That's why teachers teach it that way. But think like this, what I'm trying to talk over here. But if you don't get it the first time, don't worry. We have, 4 classes a week until the 18th of May. So we have plenty of time to get it. But let's move on now. Oh my God, can we skip this? Okay. When zinc is added to aqueous iron sulfate, the temperature of the mixture increases. The equation of the reaction is shown. Zinc reaction with iron sulfate to produce zinc sulfate and iron. Classic displacement reaction, right? Because zinc is more reactive than iron. A solution is transferred 25 centimeter cube of 2 moles per decimeter cube of iron. That's so much information. Into a beaker. The temperature of the solution is 22.0 degrees. Students then adds excess zinc to the aqueous iron sulfate and starts the timer. So it's a rate question again. Student stirs the mixture with a thermometer and measures the temperature at 1 minute intervals. It's not a rate question. It's a energy question. Time in minutes and the temperature. So temperature peaks at the first minute, then it's going down. Why is it going down, guys? What's happening? It's clearly an exothermic reaction. Temperature shoots up, but then it starts going down. Why is it going down? Because the heat is being lost to the surroundings, right? I hope that makes sense. That's my catchphrase. I hope that makes sense. As soon as the zinc is added to the aqueous iron 2 sulfate, the temperature of the mixture increases. What can you deduce about the reaction? Because it is an exothermic reaction. It's exo. exothermic reaction. Why do temperature readings in the table decrease from 1 to 6? The reaction stopped place probably in the first 30 seconds, and after that is just cooling, and he's just measuring it for no reason. So the reason is heat is lost to surroundings. That's why. Heat is lost to surroundings, or the mixture is being cooled, or the reaction isn't taking place. But I think heat is being lost to the surrounding. Heat is being lost to the surroundings is the best answer. How do you draw two intersecting straight lines on a graph? Depends on the question, I guess. If the student had to continue to measure the temperature after 6 minutes, suggest the lowest temperature that would be reached. I like this question. I'll give you guys 10-15 seconds to think about it. What's the lowest temperature possible over here? If you leave chai out, it's hot when you make it, but if you leave it, what's the lowest temperature it'll reach? And like, how cold? Will it freeze? Will it go to 0 degrees? I don't think so. I don't think so. Why will it be 22 degrees? That's the room temperature. It can only get as cold as 22 degrees Celsius. Room temperature would have been my second guess if I hadn't read the question carefully. Those of you who said 25 degrees Celsius because of RTP, yeah, you're right, but you know what just happened, right? They tricked you. Okay, let's move on. Plot the graph. Okay, I'll try my best to plot it. 0 pe, there's nothing. The first is, by the way, what do you think the temperature is at 0? What do you think the temperature is at 0? Right now. Maybe that's a bad question to ask. Temperature is at 1 minute, it's 31.6. At 1 minute, it's 31.6. 1, 2, 3, there. There, right? At 2 minutes, it is 30.3. 2 minutes, it's 30.23. Note that each square is 2 degrees. No, 0.2 degrees. Yeah. At 3 minutes, 29.9. 29.9 would be here. Oh, look at that. At 4 minutes, 27.6. 27. 1, 2, 3, 4, 6. Is it here? 27.6? Huh. I don't think it's here. Is this correct? This is 29.9. Yeah, that's 29. The other one is 27.6. I'm making a mistake. 27 is here, not there. Okay, 27, 246. There we go. Yeah, can be. I'll tell you why I thought it was wrong. 5, 26.3. There, right? 6, 25. I like this one. Nope. This is going to take a while, guys. Oh, you can do that. Oh, that's so awesome. That's so cool. Didn't know you could do that. You could tilt it. Oh my God. That's a perfect line. Look at that. I did not know you could do that. Why did I ignore this? On the grid, draw a circle around an anomalous point. Do you guys know what anomalous means? It's an anomaly. Do you guys know what that means? Use your graph to determine the temperature of the mixture at 2.5 minutes. 2.5 minutes, it's 29.6 degrees Celsius. Use your graph to determine the time at which the temperature of the mixture would be 30 degrees Celsius. It would be 30 degrees here. What is that? 2.25? 2.25 minutes? I'll go with 2.25. 2.25 minutes. Right? Because it's right in the middle. Good note, Zindabad, indeed. The one which is far outside the best fit, I guess. No, I'm just English. What does anomaly mean? Shisi, our timings are 9 o'clock, Tuesdays, Thursdays, and Saturdays. I think Friday is there as well. But I think we're going with a slightly different schedule. Oh, I'll update that soon on the channel. ठीक है. How much? Oh, it's 10 o'clock already. Good thing I bought eCam. D1. Okay, let's continue. What do we have here? Use the graph to determine the temperature. Oh, can I just say one thing over here? Actually, let's do this part first. Use your graph to determine the temperature of the mixture as 0. The figure represents the maximum temperature that the mixture reaches. And I like this question. This is intersecting exactly at 33 degrees. So I'll put that here. Okay. Now what's interesting is, you know how this curve is actually going to be plotted? If you could see each temperature, or if a computer could plot it for you, this graph, what it would look like would be something like this. Something very close to this. Actually, this should come down like this, you know? It should turn into that thing. It shouldn't come down straight. But I think they made it straight because for us. Right? And what's interesting is to note that the temperature of this thing will never actually be 33 degrees. And the reason for that is, as soon as this reaction starts happening, it's also cooling it. And this is obviously an exaggeration, but yeah, this is the kind of curve you'll have. Because it takes time for all of the reaction to take place, right? It's going to probably react for the first 30 seconds or so when you mix them together. And it's still producing heat. It's getting warmer, 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 warmer. Most warm, but at this point in time, 40 seconds have already passed. So that potential heat is already lost, if that makes sense to you guys. And it's pretty cool if you think about it like that. Or if you already know that. But that's just way too much information. Okay, moving on. The initial temperature of the was 22 degrees. Calculate the maximum temperature rise after the zinc was added. The final temperature was 33 degrees, 33.0, and the initial temperature was 22.0. That's 11.0 degrees Celsius difference. The student uses 25 centimeter cube of 2 mole per decimeter cube of iron sulfate and excess zinc. Calculate the number of moles of iron sulfate in 25 centimeter of 2 mole per. Okay. Concentration is moles per volume. Moles is equal to the concentration times the volume, which is, concentration is 2 times the volume, which is 0.025. This is going to be 0.05 moles. Heat produced is given by this formula. We actually studied this equation in A-levels. It's a nice equation. I think you've seen this equation in O-levels as well. I think you do. I think you guys have seen it. Let me know if you guys have seen it in physics. Okay, heat produced is 25 times 4.2 times maximum temperature reached times 1000 times 0.05. And if we put this in the calculator, what do we get? (25 times 4.2 times 11 divided by 1000 divided by 0.05. 23.1 kilojoules per. Yeah? Oh my god, I'm exhausted. Nothing. Yeah, moles isn't there, but they've converted the moles into the mass into moles. So yeah. Because the heat produced over here, actually they haven't converted it. They're just saying heat produced per mole, and they're using moles instead of mass. Otherwise, that would be moles per energy produced per mass, right? Something like that anyway. But yeah, essentially the same formula. It is MC delta T. Right? We're done with this paper. We're done for today. Any questions? Miral? Anon? Yep. All right. GG, guys. I'll see you not tomorrow, but Thursday, very likely. ठीक है. All right, guys. Take care. If you have questions, leave a comment. Bye, Miral. Masam, why don't you come online on Zoom? Bye, Anan. Guys, take care. Techno, thank you for participating. Would be the least temperature same as the room temperature? Malik, yes. The least temperature would be the same as room temperature, but they've highlighted what the room temperature is early in the question as 22 degrees Celsius. And that's what the room temperature is currently for this question. Bye, guys. Take care. Bye, YouTube. Bye-bye.